We have, excuse me guys, we've already differentiated trigonometric functions. For example, sine 2x. Sine 2x differentiates into 2. We differentiate sine 2x directly into cos 2x. And what we used to do was we used to circle the angle and say we also have to multiply by 2 at the end. So the answer here is 2 cos 2x, okay? Now what we have to do in this exercise, we have to go backwards to what we had before. So when you look up the integration tables, okay, what's going to tell you is, if you're integrating, it doesn't give you these two formulas here. These two formulas do not exist in your tables. The only thing it gives you is this. If you integrate cos x, you're going to get sin x. If you integrate sin x, you're going to get minus cos x. So let's look what happens here, okay? I'm going to integrate this backwards. As with before, the 2 goes in completely unaffected. I look up what happens to cos. Cos turns into sine. So I change cos to sine. The angle always remains the same. Sine 2x. Now I forgot one part. What did I forget? I used to differentiate the box, so I have to undo the differentiable part. So I have to undo it by dividing it by 2. And then it's going to cancel and you're going to get sine 2x. Now let's work directly with the equation here. If you want to work directly with the equation, you got to learn it off by heart. So for example, what is the integral of, we'll go for sine 2x this time, or sorry, sine 3x. What is the integral of sine 3x dx? What we can do here is this. We can say that a is what, guys? What is the a value? A is 3. Therefore, the integral is going to be minus 1 over 3 cos 3x plus c. Let's check this out. If I differentiate this, what happens when I differentiate cos 3x? It turns into 3 sine, actually minus 3 sine 3x. And when you multiply that by minus a third,
minus 1.
and then it's just sine 3x back where you started. Okay? So you have two ways of doing it. You have the way of just using what's in your table and figuring it out more organically, or you can try and learn this box off by heart. Choice is yours. Okay? So we'll get into some questions now.
Will you ever be asked to do a tan function?
No. Okay, so what we get here, guys, is this here. We'll do number 3 and we'll do number 5, and let me explain what happens to 3 and 5. Okay, so excuse me, with number 3 could be rewritten this way, believe it or not. It's the same thing. Remember I said you can always take out the constant. Remember I was saying that this number doesn't affect it, you just put it down and treat it as normal. That's the same thing as moving the 3 outside it and having the integral completely separate, and then multiply 3 by the answer. Now let's work this out. I'm going to try this using what's in my tables only. Okay, so what's in my tables only is that cos x turns into sin x. So let's figure this out. Cos 3x will turn into what? Sin 3x. But the problem is, when I differentiate it, I'm going to have to multiply by an extra 3. I need something to undo multiplying by 3. How do you undo multiplying by 3? Divide by 3. So what I'm going to do is, when I do an integration, I change cos 3x into sin 3x, and whatever the derivative is of the angle, I divide it by it. Okay? And then we have our plus c. But what did we forget about? The 3. Multiplying the 3, and what happens? So the answer is sin 3x plus c. Alright, let's try another one. The next one we're going to try is question 8. So I've done question 3, and now I'm going to do question 5. Excuse me, question 5. Now look at question 5, guys. Question 5 is done like this: 8 brackets cos 2 theta minus sin 8 theta d theta. Now let's do this logically here, okay? The 8 is on the outside, not affecting anything at this point in time. Okay? How do you integrate cos 2 theta? What does it say in your tables? It says cos turns into sine, and sine turns into minus cos.
Cos turns into minus sine.
No, this is for integration, not differentiation.
Yeah.
Integration is opposite. Okay, so lads, cos turns into sine, so what's automatically in my answer? Sine 2 theta. Everybody happy with that? How do you undo the derivative of the angle? By a half. What about this one here? Sine. Sine turns into minus cos. What's minus minus? Plus. So we might as well just put in a plus cos. Okay? Now, cos what? Cos 8 theta. And what do we divide that by, Simon?
8.
8. Okay? And what you can do then is you can have your plus c at the end. Okay? Now what's 8 times this? Going to be 4 sine 2 theta plus cos 8 theta plus c. Right? There, that's your bread and butter of this exercise. Okay? The harder version of this now comes in this form here. Okay? I'm going to show you 2 different types of questions. Okay? The first type I'm going to show you is question 8. Question 8 can be written 2 different ways. It could also be written as this. Is everybody happy that these 2 questions are exactly the same?
Yeah.
You can multiply in by constants. You can take constants out, but you can't take variables out. Okay? Now, once we realise that these are both the same, what I'm going to ask you is, you're going to go to your trigonometry equations. Your trigonometry equations you're going to use for this particular exercise are going to be located on the top of page 15. Page 15 of your tables at the top. Now, what I'm reading here is cos A sine B. What I'm looking to find out is what is 2 cos A sine B in these tables. And as it turns out, it's the very first formula. 2 cos A sine B is what, guys? It's cos A plus B plus cos A minus B.
No, sine, it's the last one. Sine A plus B minus sine.
Oh, sorry, I'm wrong. Sorry, excuse me. Sorry, the second one was a sine. So it's cos followed by a sine. Excuse me. So it's actually sine A plus B minus sine A minus B. Now guys, what happens here is you're going to change around. A is 6x, so it's going to be 6x plus x, and this one here is going to be 6x minus x. What does it turn into? The integral of sine 7x minus. Now the rule is, guys, to identify trying to do this equation in a test is, the rule is you're never allowed to have the 2 sine functions being multiplied by each other. You're never allowed to have 2 cos functions multiplied by each other. It always has to be added or subtracted to integrate. Now it's a lot like question 5. So if we go to question 5, what we can see here is that, so it's a lot like question 5, okay? So what happens when you integrate sine? Sine turns into?
Minus cos.
Is it minus cos? And what does cos turn into?
Sine.
Sine. So let's look at this. It's going to be the integral of, what happens when sine 7x turns into what, guys? Minus? And all over? What about this one here? Minus minus? And what is minus minus cos? Plus, so just turn it into plus. So plus cos 5x all over, and then plus c. Now, I would do the ones that have no, see the way these ones have no 2 in them? See the way there's no 2 here?
Yeah.
There's a little trick to that. Do you want me to try a trick? I'll try and find another one that has limits though, and does the same trick. What I do is I change it into this. A half, 2. Am I allowed to do that?
Yeah.
What's a half times 2? Exact same thing. So what I do is I treat this question separately, like I did in question 7, and then just multiply the answer by a half at the end.
Right.
Okay? Now, we'll do another one like that though. I just wanted to do one that actually had some limits in it. Okay, so here it is here. Number 15. Express cos 2x sine 4x as the sum or difference of two trigonometric functions. What I do first of all is I'd say, okay, I know that on the top of page 15 they always come in twos. Do you understand? So I'm going to just do this: a half 2 cos 2x sine 4x. Then I'm going to say that a equals what? What does a equal? B equals 4x. I'm then going to look up the formula that has this in it. What's the formula that has this in it? The formula is going to be, it's going to be a half times the formula. So what is that formula? It's going to be sine a plus b minus sine a minus b. Now guys, there's a trick in this as well, right? Let me show you. What's a plus b? What's a plus b? Sorry? 6x. What's a minus b? 2x minus 4x minus 2x. Now, there's a rule here. The next rule I'm using, unfortunately, the next rule I'm using is a rule on page 13. On page 13 it says this. It says that sine of a minus a, sine minus a is minus sine a. By that logic, what is sine minus 2x? And what is minus sine 2x plus sine 2x? So this question here is going to turn into a half sine 6x plus sine 2x. Tell me something, have I even integrated yet? No. I've just answered question 1. Haven't even done question 2 yet. Okay? So question 2. Integrate this function. Excuse me. Integrate this function. Now how do you integrate this function? It's the same as the part 1. So it's going to become a half the integral of pi over 6 to 0. And what we're changing this into? Sine 6x plus sine 2x dx. Now guys, look at this. This one's the first one I've done with limits today. Okay? So we can move into half if you want, but we can do that after. We'll do that in a minute. Okay? So the half is still hovering on the outside, not doing anything. Now what is sine 6x? Matthew, sine 6x when you integrate it. Okay. Sine turns into minus cos. Okay? Sine turns into minus cos. So what's the answer then for this one here when you integrate it?
Minus cos 6x.
All over?
6.
What about the second one? Minus
Cos 2x over 2.
All over 2. Okay? And you still have your two limits here, right? Now, you're well entitled to multiplying in by your half now. So we're going to multiply in by that half. And what's going to happen then? We're going to get minus cos 6x all over.
3.
It's 12 because they're both on the bottom. And the other one's going to be cos 2x all over
4.
Now, what we have to put in is pi over 6 and 0. Now, here's the rule here. To make this easy, lads, if x equals pi over 6, what's 6x going to be equal to? Pi. Because you just multiply it by 6. And what's 2x going to be equal to? It's going to be basically 2 pi over 6, which is the same thing as pi over 3. So look at this, guys. We're going to put in both limits now. The first one's going to turn into minus cos, what's 6x again? Pi all over 12. And this one's also going to turn into cos, what is it? Pi over 3 all over 4. And then we got to take away what? Minus cos 0 over 12 minus cos 0 over 4. Now, unfortunately, you have to put all of this into the calculator because none of it will disappear, so to speak. Now what's cos pi in your calculator? Cos pi is what, guys? Cos pi? Minus 1. What's minus 1? So that's 1 over 12. What's cos pi over 3? A half. What's a half divided by 4?
4 over 2.
It's an 8.
Oh, I see.
Yeah, okay. It's 4 times smaller than a half.
Yeah, I got you.
Okay. What's cos 0 in your calculator? Cos 0? 1. So it's minus a 12th. And what's cos 0 again is 1. Minus a quarter. Now lads, look at this. What we're going to have now is going to have all these fractions together. So we're going to get a 12th minus an 8th plus a 12th plus a quarter. So we're going to get a 6th and an 8th minus a quarter. That's 2 eighths minus a quarter, which is minus an 8th. 6 minus an 8th. We're going to put them into 24ths, which is going to be... It is plus an 8, you're right. So it's going to be 4 over 24 plus 3 over 24, which the answer will give me is 7 over 24. Tell me what to do.
Well, if you just need to integrate it.
And what about this tree? What do I have to do with the tree?
Leave the tree outside.
Leave the tree alone, don't do anything with the tree. Fair enough, okay? How would you integrate sine 4x?
Sine is minus cos 4x over 4.
Minus cos 4x all over 4, that's perfect. And now you have your pi over 4 and 0.
Then you multiply the 3.
Okay, just yep. So I'm just gonna do that by rubbing it out. So it's gonna be minus 3 cos x over 4. That's perfect, right? Minus 3 cos 4x over 4. Now, if x equals pi over 4, what's 4x equal to? Pi. Alright, now do your limits. So how do you do your limits?
You just swap pi for the x.
So it's going to be cos what? Cos pi all over 4. Then after that, minus
3 cos 0
all over 4. Okay, after that,
then you just do some that.
what is cos pi? Minus 1. Minus 3 times minus 1?
3 over 4.
Okay, minus
3 over 4 again.
so it's going to be 3 quarters plus 3 quarters. Sorry, 6 over 4. 6 over 4 will lose you 2 marks. Why? Don't want that as 3 over 2. Okay, so lads, that's